Yeah, it works. So, hi. I am Wojciech Mikołajczyk, and I will tell you about our journey towards MLOps, from a greenfield to quite robust platform in Fandom. So, I am a senior machine learning engineer at Fandom. I started my career by being a Python developer. I made applications in Django. Then I tried business intelligence stuff and made several dashboards in Power BI using SQL. Then went through the research part of machine learning, doing data science, and now doing machine learning focused mostly on MLOps. I'm also co-creator of ML Workout together with Martin, who is here also. After work, I play the piano. That's my biggest passion. I'm a graduate of music school, but I still love to do it. And yeah, I work in Fandom. So if you are not familiar with Fandom, Fandom is like a Wikipedia, but for the pop culture. So we have articles about different characters, series, games. For example, we have an article about Quidditch from Harry Potter, which looks like a Wikipedia. The technical core is shared, partially at least now, as Wikipedia. And yeah, we do in Fandom machine learning. We do it in a configuration that we have a data science team, which is purely focused on the research, on training models, and they are in the United States. And we have a machine learning team, which is about MLOps, and we have it in Poznań. We do some text classification. Yeah, we have like 40 million of articles, so we mainly process text. We do name entity recognition and Gen AI stuff. And I will describe our starting point and a little bit of context. So our team was created like machine learning team over a year and a half ago. And we started in a situation that we already had our content. So you can see on this Fandom articles on the left side. And we classify them with machine learning models. Fandom brings profits by displaying ads. So if we are able to classify our content better and show it to the advertisers, then they want to pay us more. So for example, if we see on this Geralt Witcher article, we can tell that this vertical type is a book, it's also a video game. This page type is about the character, the other types are examples, some item, object, quest. The video game genre is RPG. We can choose out from other like first-person shooters, strategy, and other stuff. Like I mentioned, we've got quite a lot of articles, like 40 millions. And then we use this data to target ads, also for analytics and other stuff. And the way we developed the machine learning models and served them this 1.5 years ago looked like that. The data science team trained the model on Fandom articles, and they made it mostly in Jupyter Notebooks. Then they passed trained models to machine learning team, to us, to deploy it, and the documentation was on the Confluence, like where are the model files, how the model is performing. That was a lot of typing, a lot of copy pasting there, and also this RGZ stands for the model files. It was like pickled model if it was in scikit-learn, or PyTorch files if it was deep learning based model. And then machine learning team had to deploy it and serve to run predictions on all our articles data. And we had several problems with that. Challenges. We treated that as a growth opportunities, but there were problems. So first, it took us a day of work to deploy a model, literally. We had to look through the documentation on the Confluence, look for the model files, copy them to the different places. Then we had also to provide the Docker image for serving, build that, deploy. It took a lot of time. And then, if you are familiar with the SageMaker, there's a way that you need to prepare the model archive, you need to put there the inference code and the model files, and we had to do it manually. So that's why it was really tedious and time-consuming task. Second problem, that was multiple versions of model. So if the data science team trained in second or third version of model or in Jupyter Notebooks, it was really hard to find what is where and to compare it to be able to deploy different versions. The third point is training mess. No, literally, they were putting it on a notebook, on Git repository, sometimes not. It was challenging. And in the whole process, we had a lot of copy pasting, which is time consuming, and also it makes a lot of places that you can make mistakes by putting the old model path or changing random thing. And 1.5 years ago, we started our machine learning ops journey. And we made the first step by using experiment tracking tool. And we selected MLflow for that. You might be familiar with. It's a tool for the experiment tracking, and this is how it looks in practice. It's a web application. You can see here the datasets, parameters, metrics, tags, and artifact things, but what we used was parameters, metrics, and artifacts. So as a parameters, we stored the model parameters set before the training. Also, we typed here some paths to training datasets, some hyperparameters to the model. Then after the model training, we put metrics here as an evaluation. It was a classification model, so you can see here metrics like recall, F-score, precision, and also the accuracy. And the model artifacts, it was stored after the training in one place. So it's simplified a bit things for us because we didn't need to look for so much things in the documentation on Confluence, but we were able to just look on the link on the MLflow, link to training, which data science team provided to us, and know everything from there, which data it was trained on, how it performs, and when we needed to deploy it, where are the model files, also requirements files, so we knew which versions of the Python packages were used for training, so it improved a bit. And that was our first element of the ML platform. MLflow for experiment tracking. And going back to list of our problems, it addressed partially 3 of our problems. So multiple versions of model, hard to manage, hard to compare. Now it's much easier because every model, every run has its own entry in MLflow. We can compare them, we can deploy them, it's better. Model training mess is partially solved, like we still have this notebook element which isn't great, but we had better tracking, so it's good. And less copy pasting because now we don't need to look for the model paths so hard, we have stored them in MLflow. It's better. Okay, the second step is about continuous integration, continuous development pipelines, and we focused on part of optimizing the flow of delivering Docker images for SageMaker model, because like I mentioned, if you deploy the model on SageMaker, you need to provide the model files, you need to provide inference code, and also you need to provide the Docker image which will be used to serve. So we've developed our code using GitHub. So we used GitHub Actions to read the code, to build the Docker images, and to put them in Amazon ECR, Elastic Container Registry, which is the Docker image repository, and the SageMaker can read from Docker images. So yeah, that was rather quick. That's the second element. And we addressed one thing, Docker image for serving. Previously, we were building it manually on our local machines. We had also some funny mismatches sometimes related with ARM or AMD architecture, but now it's unified, it's in CI/CD, it's automated, it's better. Third step, the deployment automation. For that, we developed a Python script which downloaded the inference code from our repository and also when passed the model identification or the training job ID, it was able to download the models from the MLflow and build the model tar.gz package with inference code and with the model artifact itself, and put it in the SageMaker as a registered model. So then in one command we was able to serve the model further on the SageMaker. And yeah, this is the third element of our stack. And it addresses three more things here. So the thing about the deployment of the model as a SageMaker, and the problem of having to spend all day working to deploy the model. Now, when we have this Docker image automatically built and stored, and we are able in one command to prepare the model for the SageMaker, now it takes us like up to 15 minutes with double checking if everything went right to deploy model instead of putting a lot of manual work. And the fourth problem with copy pasting is really reduced to not being such a problem at all, because we do not need to copy the model artifacts to paste the paths. It's just automatically solved. And after having that, we went one step further to replace the training in Jupyter Notebooks with introducing the training pipelines. And yeah, this is like 3 level of maturity in development models. So yeah, Jupyter Notebook, most simple, but has these disadvantages. Python script is more reliable, but the ML pipeline is like the big brain move. So we selected Kedro. To be honest, we evaluated Metaflow and Kedro in Fandom. Both frameworks could handle the task. We selected Kedro because it seemed like more reliable solution for production grade training. And in Kedro you can define pipeline, a DAG, which can look like this one on the left, with steps you need to perform to train your model. And very, very high level overview of the organization of stuff here is that on the right part of the screen, you can see the pipeline. You can see 3 nodes here. First is about prepare data, second to train model, and third to evaluate the model. You can define the inputs and outputs to define the flow of the operations in the DAG. You have the support for the data catalog, so you are able to define the paths where the data set should be loaded, from which location or where to start, and the parameters for the model training and basically for each node of your DAG. And on the left side now is the visualization of this pipeline. So at the top, we have the full DF, the data frame, which is defined in the data catalog. It contains our all training data. Then we have the prepare data node, which you can see that the full data frame is in its inputs, and in outputs it's train, validation, and testing data sets, which are displayed below. And then they go to the train data node, which train model node, which trains the model and outputs the model as an artifact, which is used in evaluate model node together with the training, validation, and the testing data set. And the result artifact of that are model metrics. And what we like in Kedro is that you can focus on the logic of the processing and what needs to be done, and you don't stick with particular cloud provider or the solution, because you can take Kedro and deploy it on Airflow, SageMaker, Azure, Vertex AI in Google, using Prefect, Kubeflow. So you can choose by using appropriate plugins or which supports different runners. So that's cool. Currently we are using it using SageMaker and SageMaker pipelines. But yeah, we are free to change it potentially in the future if we would want to. And this is what we did. This is our improvements in 4 steps. So we had introduced experiment tracking tool MLflow. Then we worked to optimize the model development, the deployment process by building in CI/CD Docker image and uploading them, by automating the way we create models and deploy them in the SageMaker, and by replacing the Jupyter Notebooks with the Kedro pipeline for model training. And this way we solved all our biggest problems, at least for now. So yeah, we are done. But to be honest, building a machine learning platform is a journey. Rather, we are thinking about it as a constant improvement, so we are not done yet. The experiment tracking tools greatly improve model training process, because then first we are able to compare the models, manage them easier, and also in the part of model deployment we can easily get model artifacts with the Python version, with the requirements, with every information we need to provide the model serving. And yeah, model development deployment automations saves really tons of time, especially when we remember the environment we started from, containing a lot of manual work. Introducing model training pipelines greatly improves the maturity level of machine learning development in an organization. And yeah, this is something in that, because now we have a tidy training code, not messy notebooks. It's easier to review it in Git to maintain that, and also more tidy way and more convenient to train multiple pipelines with different parameters and manage all the stuff. And yeah, as summing up, this is the platform. We focused here mostly on improving model training and model development by introducing those tools. And we are still continuing on our MLOps journey with a nice team of, here are 2 photos. First is for our walk in the woods with Jacek, Julia, and me. And the second one is from the Big Data Technology Warsaw Summit, which we were recently, with me, Julia, and also Sebastian, our new intern, who recently became a junior member of our team. And yeah, that's all. And I want you to encourage, on my last slide, to visit our YouTube channel, when together with Marcin we are creating practical machine learning tutorials, mainly on YouTube. It's called ML Workout. You can scan the QR code to get there. And that's all. Thank you.
Okay, are there any questions?
Thanks for a great presentation. Yeah, I was actually going to ask about the storing models in MLflow. Right now, at this stage of development in your MLOps platform, do you store only models, as in model weights or binaries purely related to model, or also something related to preprocessing, for example?
We stored model weights. We store one thing related to, could be treated as pre-processing. We store also the tokenizer. We take out of the box, so we didn't have to, because we can download them, but it was like, if we will change something, then we had the process to store the tokenizer with the model.
So thank you for your presentation. And my question is, what do you use for data versioning? And if you don't use anything for that, could you recommend some tool, or what do you use for that? DVC or data lake? Oh.
We are not using any tool for their data versioning currently. Our data is saved on S3 buckets with the versioning there, and we are working to have different data sets named differently so they do not override themselves. but I used previously DVC tool, and it's quite nice and convenient, so I can recommend that.
So I'm curious, how often do you add models to your entire model database? So I have a second question behind that because I'm really curious in when is the right time to go from having a Jupyter notebook to a pipeline, right? Because you start with experimentation and then, yeah, there's all sorts of problems there.
Okay, how often it depends on the projects that are ongoing, but when they are, we got several version of models, you know, a month. It really depends. I would say that in the basic version of the Kedro, I can recommend it. I would say if the team is a little technical, not purely scientific, that it won't be too hard for them to incorporate that. You can start with that from the beginning, maybe not without using all the fancy stuff Kedro provides, but the simple pipelines, from my perspective, is a better approach.
Yeah, quick question. Why did you decide to use separately MLflow and not to put it into SageMaker? Because I'm not quite sure why. I assume it's very similar to Azure, like Azure Machine Learning, which is also built on top of MLflow. So why did you decide to do it separate? Is it because of the costs or?
Yeah, so we didn't want to have such a heavy anchor on this SageMaker tooling. Yes, we are using that for the model serving for now, but we don't want to do that if not necessary. Also, we liked the way MLflow solved the problem, and it was convenient to use by us.
I have a question. Do you use Python for pre-processing? And also, second question, what volume of data do you process in pipelines?
Yeah, okay, yes. So we are using purely Python for that. We mainly have now BERT-based classifiers with trained classification heads. We don't use any additional different than tokenization pre-processing tools. And about the data volume, if we introduce the new model, we need to run through all our 40 million articles through that. I don't remember, but it's, I guess, several hundreds of gigabytes of data. I'm not sure around that. So that's what we need to do one time, and then we need to schedule the inference when some article changes to do the inference again.
Great presentation. I have two questions. And first one, you mentioned that you had evaluated Kedro and Metaflow. And my question is, why hadn't you evaluated Kubeflow? And the second question is regarding MLflow. How do you deploy this MLflow? Do you have some Kubernetes cluster for that, or something else?
Okay, we evaluated Kedro and Metaflow because we wanted to have a Python-focused framework. As far as I know, Kubeflow treats nodes as containers. You can have whatever inside you are operating on a higher level there. So that's why. And about the second question, our MLflow is deployed on ECS, so Elastic Container Service. So it's like Kubernetes, but without Kubernetes. So it's a Docker image. The artifact storage is on S3, and metrics and parameters storage are on RDS, so relational database service in AWS. And I think it's working for over a year or even more without any problems. So it's quite reliable. and that might be interesting, but we are not sure. I think if it was a very okay, it might be interesting that we have actually two versions of MLflow. One is for development purposes, which we let data scientists to use, and we also use for development. And the second one for production grade stuff. So when the model is after experimentation is ready, then we want it to be trained, let's say in a clean way in this production MLflow deployment.
Hi, so thanks for the presentation. My question would be around, you mentioned now we have deployment automated, right? You have the training automated, but in the pipeline. My question would be, and this is slightly business specific to Fandom, do you actually automatically retrain the models that are in the wild, and what actually triggers that? And the second related question is, what's the approval process between them, right? Because you didn't mention, is it something that, people are still looking for the metrics and saying this is good to go, or you are actually went past that?
Okay. So, sorry, what was the first question?
Basically, do you retrain the models?
Okay. So we don't have automation for that. We have trained models is trained for some time, and if the data science team or someone comes to, let's retrain the model, then it's retrained and compared. And about the second half, the second question, the approval process, it's first we are evaluating them and data scientists are looking on the metrics. And then usually we have someone from the business which asks us to do some predictions on the data they are familiar with, and then look on the results and tell us if it's good enough to be on the production from their perspective. So it's a little bit of gut feeling part here and manual work, but this is how it works for now.
Yeah, human in the loop, right?
Yeah.
That's from business side,
Yeah.
not your decision.
Yeah, state of the art human in the loop, yeah.
Okay, thank you for the presentation. I have maybe less technical but more presentation-based question. You showed the problems that you struggle with, or maybe challenges or the growth opportunities. Maybe I should say like that. So my question is, what was the biggest problem, and in your opinion, and how much time did you spend on that? And on the other side, on the other hand, what was the easiest task that you did from all of these growth opportunities?
I think the biggest problem from our perspective was the pain of deploying the models, because it was really a lot of communication going through the Confluence to the documentation, looking for the files, ensuring that they are the right ones, not the outdated ones, then copying the configuration, maintaining the documentation of models on the production, because we had to keep the track of that. Building manually those model packages, uploading them, building Docker images, noticing that some packages are mismatched, so building them again and hoping that it will work and other stuff. So that was the biggest pain point from our side. And the second question about I understand the quickest win, the smallest changes from those ones. I think it was I'm not sure. Docker images or putting the simple Python script to just download code, download the stuff, the artifacts from the MLflow and upload them, because it's made our work a lot of easier.
Thank you for the presentation. I have a question about this Python script, because you told that you have the GitHub action pipelines workflows, but you still have a separate Python script. Why not combine those two?
Maybe in the future we will. It's our journey is still in progress. Maybe we are not there yet, but also, as I mentioned, we have 2 deployments on this ML flow, and we have this human in the loop, also the approval process. So it was easier for us for now to have like that we need to run the script and not create some conditions and put it in the CI/CD to make it automatically. So that's probably in the future we want to be there.